Hello guys, in this video I'm going to show you how to solve unique generalized abbreviations. So, given a word, write a function to generate all of its unique generalized abbreviations. So, generalized abbreviations of a word can be generated by replacing each substring of the word by the count of characters in substring. Take the example of AB, which has 4 substrings: empty, A, B, and AB. After replacing these substrings in the actual word by the count of the characters, we will get all generalized abbreviations. AB, 1B, A1, and 2. Right, so let's get into another example, BAT, right? So here we have the first choice will be replace the empty substring, so it will produce the same result, which is BAT, right? The next choice would be abbreviate the last character, right? The last substrings, which is a single character T. So we have BA1. Next, abbreviate the middle characters, B1T. Next, abbreviate. Here it is 2 last characters, so it's B2. Next, abbreviate the first character B. We have 1AT. Next, abbreviate first and last characters, 1A1. Next, abbreviate first 2 characters, so we have 2T. And the last is to abbreviate all 3 characters, so we end up with 3, right? So in order to solve this problem, the most easy way to come up with it is to just try to brute force all the possibilities that we can generate from the original strings, right? So in order to brute force all the possibilities, we start with here I've written down all the 3 structures that wanna represent how wanna generate all the possibilities, starting with a empty string, right? So as you can see, at each level we're gonna work with 1 character from the input, right? So here in the first level we're working with B, so this level from each input from each string in the previous level we have 2 choices. So in the previous level we have 1 empty strings, means here we have 2 choices, which is either at B or AB as the next character, or abbreviate the first character, which is uh, which means we end up with 1 here, right? So we're done with the first level. So it will produce 2 strings B and 1. Next level we will work with A, which is the next character on the input. Again, from each string from previous level, we're gonna have 2 choices. For example, here with B, we have 2 choices, which is add the current character, which is A here. We have BA, or abbreviate this character, abbreviate current characters. We abbreviate the A here, so we end up with B1. Okay, we're done with this B. The next is 1. So for this string, again we have 2 choices. First is to not abbreviate the current character, which is A. So we just add A to the current string, so we have 1A. The next choices that we have is to abbreviate the A, so that we abbreviate the A, so it should be 1 and 1, right? We abbreviate the A, so we have 1 and 1. Actually, in the final results, we wouldn't want this form of string, but instead it would be but instead we will somehow group these number into like this. Like if we have 2 1 that next to each other, we will combine into 2. For example, here we have 3 1s, we combine into 3. Okay, so next level we'll work with T. Again, BA, we have 2 choices. Add T here, BAT, or we decide to abbreviate T, we have BA1. Okay, done with this one. B1, we have 2 choices. We add T here, B1T, or abbreviate T. So we add 1 here. We end up with B11, which is not the form that we want, but later we will, in the last step, we will somehow combine into B2, 1A, 1AT, 1A1, 2 choice, right? Same here, 1 1. We have 2 choice, add the current character T, 1 1T, or abbreviate it. So add 1 here, 1 1 1. Okay, so as you can see, we are done with this with this tree actually, but what we want is, but there are some strings that is not complete. yet, which is like this one. We want this should be big, it should be b2 instead, and this one should be 2t, and this should be 3. So there must be a way, must be a easy way, easier way to uh, to work around this uh, issue. Okay, so how wanna how wanna work around these issues? As you can see, what we are doing here is like we are building uh, current strings based on the last level, right? So we're kind of like mixing the numbers and the characters into one strings, right? So like from here, 1 1, and if the next character is T, we just add T here, but it should be 2T instead. So it seems like we want to transform the numbers into, we want to accumulate the numbers when we are trying to add a characters, right? So one way we can actually we can consider each of these as a nodes in our tree, right? So it would be node, right, which contain informations like what we need here is a current string, right? Current string. For example, we start with empty strings, and at each node we need to know what characters we are working at. So additional, we will work with one character from the given input, right? So actually, the piece of state here we need to maintain is the index of the current strings, right? Index, it'll be 0 initially, and based on this index, we will know that what characters we are working at and what would be the next what would be the next um, what would be the next character of the next level. Like from here, it will be index 1, index 0. At this level, it will be index 1, and the last will be index 2. And yeah, so we probably want to stop when the index e, for example, in this case, 3, 0, 1, 2, and when it's 3, we want to stop. Okay. Actually, here we can separate it here into strings and numbers, right? The current, let's say count, for example. Count we start 0, right? So if we try to abbreviate the current character, we will increment count. For example, here we will increment it into count will be 1, right? But the strings, we don't want to mixing it up here. So in the next level here, if we decide to add a here, which is not abbreviate the current character, I will bring the count into the current strings before add a character, right? But if you go this way, which is abbreviate the current character, I will not add 1 into the one more, I will not add 1 to the current string here, but I will increment the count instead. So it will become 2, right? So like here, the count here will, because we add 1 back to the string, the count will come back to 0 here. Okay, so again, this way we have two choices, T or 1. Let's take, let's go this way. Here, for example, from this string, we have two choices. Either add the next character T or abbreviate the T. If we decide to add T, we decide to add T to these empty strings, we probably want to add 2 first, right? So 2 here, T here, and now it becomes 0 count. But if we decide to abbreviate the connector, I will increment count 3 here. So this will be transformed into 3 at the end, because we are at the last level here. So it will be 3 here. So that's how I wanna separate the number and characters part. Right. So let's get into coding now. So class node. We need constructor that keep track of 3 piece of state: constraint, index, and count. Okay, this constraint equal to this constraint index. This dot count equal to count. Okay, so we start here. For this kind of tree traversal, we can use because we're going level by level, so I will use depth breadth of search, which means we need a queue, right? We need a queue initially empty, uh, the first element in the queue will be this one, this empty string. I will push, but I will abstract it into a node, which is new node. The string is empty, index is 0, and index is 0, and what else? The count is 0 also. Okay, so so at the last level, when we are done, probably want to because what we need here is strings, right? A list of strings. So for example, probably when the index reaches the string size of original strings, we will start adding it to a list result. For example, return result at the end. So we want to uh, keep processing as long as we have something in the queue. Length, right? So at each iterations, I want to process one node from the queue. Node L will be what is that? Queue.ship. Okay, the node L can be destructured into its property constraints, index, and count. So for each node, we can have two choices to build it up, right? So we have two choices. The first choice is to add the current character, which is actually the word at index, at this index, right? Or number two is to, as we described earlier, either add the character or to accumulate the count increment count, right? Okay, let's go this one just increment count. So I will pop this one out from the queue and add back to new nodes. Okay. So the first new node will be queue push new node. The first new node will be will be a node with count is calculated by this count plus 1. Constraint is stays the same because we decide uh, to abbreviate the current character, so we will remain this uh, yeah, constraint index will be plus 1 because we're done with the current level. The new node will, for the new node, we will is actually the node of the next level. So for next level we want to process the next character. The count will plus 1 here. The next choice would be so before adding the character here, as we described earlier, we want to add the remaining count to the constraint first. So add constraint, new constraint will be constraints plus plus what? Plus constraint plus the count, but only if let's say this initialize constraint to new constraint to constraints, and if count is greater than 0, I will add it to new constraint count here. Okay, and here the second choice, it is a node with the last step here in new constraint at the current character, which is what at index. So at this choice we are adding current character with the index to constraints, but before adding the current characters we want to accumulate the count if it's greater than 0 here. So here just new constraints index will be index plus 1, count will be come back to 0 because we have just add the count to the constraint, so here it becomes 0. Okay, here 2 choices. Okay, we're done with 2 choices here. So for each iteration we process 1. Okay. So probably here we want to stop it somewhere. So here if Oh, I think we can put it when the what if the index is equal to word dot length. So for example here, like this, if we convert this level, it means the current index now is 0, 1, 2, 3, and 3 is the same as the original size. We don't want to process these strings anymore, but we want to add it to our result. So here, if index equal to say, I want to add the constraint to result and else. I want to do this. I think that is it. Let's run a test. Just 10 and 6. Okay. Oops. It. Hmm. Hmm. Actually, here we probably missed something at the end. So here it should be 1A1 instead. So here it should be 3. Here it should be B2, BA1. So probably we miss something at the last iterations. It's probably we can process it here. So like example here, like we are here, but we forgot to add the last piece of informations. So here it could be because of the cow hasn't been added to the constraint. So probably here, if we do have a cow, a is greater than 0, I will add it up to the constraints. So here the cow is 3, probably will be added here. The cow is 2, added here. 1, BA1. So it should work now. Whoops. Oh, come on. So let's say we will push. If we have the cow is greater than 0, we will push constraint plus it's okay. We can change it into let instead so that we can modify it. Whoops. There's still something wrong. Okay. It works, but actually it printed out in different order with the test here. So I want to, so the result is the same, but because we run it in the way that we process the queue could result in different order. So now it is correct now. So that is it for this problem. Mm. Thanks for watching. See you on the next video.